Okay, let's take a look at this one. So it looks like we're solving, we're going to make them a little bit harder today. Okay, so we're extending what we did yesterday, basically. So I'm going to start by moving this to the other side. So we're going to have to probably add a little bit more algebra into this than what we were doing yesterday. So cotangent of x, cosine squared x. How do I get this 2 cotangent to the other side? Not divide. I'm going to subtract it over. Okay, so subtract 2 cotangent of x equals 0. Okay. What can I now factor out? Yeah, we can factor out a cotangent x. Cosine squared x minus 1 equals 0. Oh, it shouldn't be a 1, it should be a 2. Okay. Remember zero product property? We're going to apply that right here. Okay, so I'm going to go that the cotangent of x equals 0 and cosine squared x minus 2 equals 0. So all I did was zero product property way back from when we factored in, I don't know, August. All right. So the cotangent, remember, is the what over the what? Cosine over sine. If I want it to turn out to be 0, that means the cosine has to be 0 and the sine has to either be plus or minus 1, right? So I'm looking for the point 0, 1, and 0, negative 1. What radian measures does that happen at? And 3 pi over 2. Good job. Okay, so there's part of my answer. I need to now look at this other half. How do I move that 2 to the other side? Add it. So cosine squared equals 2. How do we undo the square root? Or sorry, the square. We square root it. We got cosine x equals the square root of 2. Is that on our unit circle? Just the square root of 2? No. No, it has to be divided by 2. So this here is outside the domain. It isn't. It's an extraneous solution. Remember extraneous solutions? All right. So all we have is the pi over 2, 3 pi over 2. Okay. All right. Let's try that again, or try this again. So I am going to move this over. How did we move it over the last time? Yeah, we're going to subtract it. So sine squared x minus 2 sine x equals 0. What do you think we're going to do now? Good. We're going to take out a sine x. So we're left with sine x minus 2 equals 0. All right. And we've got to do zero product property again. So sine x equals 0 and sine x minus 2 equals 0. So where, for the sine is the y value, right? So I'm looking for where the y is equal to 0. So where does that happen? Okay, so I'm glad you said 2 pi. All right. Do you see how this is a bracket and this is a parentheses? That means that the 0 is included, but the 2 pi is not. Okay? So instead of saying 2 pi, we would say 0, because they're at the same place. Okay? That's what the difference between the bracket and the parentheses is. All right. This one, I got to add the 2 to the other side. It's 2 on our unit circle. Nope. So this side is extraneous, so it's just the 0 and the pi. All right, we good with 14? All right, this one's uglier. Okay, only if we let it be, though. We did one like this the other day where we replaced the signs with x's, right? So we've got 2x squared minus x minus 1 equals 0. Do we know what to do with that? Yeah. What do we have to do?
Magic X.
Good old magic X. So two numbers that multiply to negative 2 and add to negative 1. Negative 2 and 1. Okay. All right. Do I need a box?
Yes.
Why? There's a leading coefficient. Good. So we've got 2x squared and negative 1, and then negative 2x and 1x from the magic X. All right, two numbers that multiply to 2. That's not that hard of a question. 1 and 2. Everybody in this room should be able to do that. Okay? Ellie can do that one, so you guys should be able to do that one. Okay? All right. Good news, the 5-year-old can't do that yet. So.
The magic X, why is it negative 2 on top?
Oh, it shouldn't be negative 2. What should it be? Oh, why is it negative 2 up here? Because it's 2 times negative 1. Okay, does that make sense? All right, I know it's been a while. It's okay. All right, so we decided 2 and 1, right? So where's my 2 got to go? On the side on mine, and then we'd put the 1x on the top. I don't have to write the 1 in front of the x. How many times does 2 divide negative 2x? Negative 1. And how many times does 1x divide 1x? And then you check it. 1 times negative 1 is negative 1. Okay, so what this is saying is I have x minus 1 and 2x plus 1. Instead of writing x's, though, what are we going to write? Sine x. So I'm going to say sine x minus 1 times 2 sine x plus 1 equals 0. All right, what property are we going to use? The zero product property. We should all know that one. Okay, 2 sine x plus 1 equals 0. All right, now it looks like what we've been doing the last day and a half here. So I'm going to go ahead and move that 1 over. How do we move the 1? Add it. Okay, so that's the y value, right? Where is the y value equal to positive 1? Just at pi over 2. So that is one of our answers. What do I have to do to move this 1? Subtract it. And then what do I have to do to move the 2? Divide it. Okay, so we've got negative 1/2 in the x spot, or sorry, the y spot. So where does that happen? What radian measures? 11 pi over 6 and also 7 pi over 6. Good, so we have 3 answers to that one. All right, I'm going to skip over 16 and go right to 17. 16 is identical to this one, right? You just put cosines in there instead of sines. Okay. So it looks like on this one that I'm going, okay. Do we see how it's in sines and cosines? Doesn't factor very well like that, right? So if I can turn it all into sines or all into cosines, that would be good. I can't do anything with just a cosine, but I know I can change a sine squared. So what's another name for sine squared?
1 minus cosine.
Good, we're going to use a Pythagorean identity. So 1 minus cosine squared x plus 3 cosine x minus 3 equals 0. Okay, what's instinct telling you to do next? Yeah, we're going to distribute in. So 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. Couldn't I combine some like terms? The 2 can go with the negative 3, so what do we get there? Negative 1, good. Plus 3 cosine x minus 1 equals 0. I know we're going to have to do a magic X in a box, but if I can avoid having a negative in front, that's really nice. So couldn't I either multiply or divide everything by negative 1 to get rid of that? So all I'm going to do is swap all my signs. So I'm not going to rewrite another whole line for that, so just swap all your signs. And that's just, we're doing that to make our math easier, okay? All right, I'm going to go ahead and switch it into x's, so it's really the same as saying 2x squared minus 3x plus 1 equals 0. What are we going to do now? Good, so two numbers that multiply to 2 and add to negative 3.
2, 1.
Negative 2 and both negatives. Okay, good. Do we need a box? Why? Good. We haven't forgotten completely. That's good. So you're going to, on this next test, there's going to be one where you're going to have to factor it like this, right? So you're going to want to make sure you're ready for that. So 2x squared in the top left, 1 in the bottom right, and then from the magic x, negative 2x and negative 1x. All right, what times what is 2? 2 and 1. Okay, I got answers that time. That was better. All right, where'd my 2 gonna go? On the side again. Coincidence, right? How many times does 2x go into negative 2x? Negative 1. How many times does 1x divide negative 1x? And check it. Negative 1 times negative 1 is 1. And then I'm going to write it instead of x's. What are we going to write? Not sine x. Cosine x this time. So we've got cosine x minus 1 times 2 cosine x minus 1 equals 0. Okay, what property am I going to use? I heard it's zero product property. Good. All right, I got to move this 1. How do we move that 1? Add it. Okay. And then, oh, I guess I could have, let me finish this one. That's where the x value equals 1, right? So where does the x value equal positive 1? 0, and again, it's 0, not the 2 pi, right? Because the 2 pi is the parentheses, so it's not included. All right, I got to add the 1 here, and I got to divide by 2. So where is the x value equal to 1/2? Pi over 3 and 5 pi over 3. I like it. All right, how we doing? We good? All right. Can I move on to the next one? Yeah? All right. I'm looking at my notes. Do you guys have a squared on this tangent? No? Okay. I'm going to add a squared in there, so let's do that. So everybody put a squared on that tangent. Okay. I'm assuming it's going to be something that's like the homework, so I want to make sure you're ready for it. Okay. Just like on the last problem, I want to get it either into secants or tangents. I'm going to choose to go into tangents, so we need to replace this secant squared. So what do we replace secant squared with? Good. And remember, we're looking, where do we find that information in the room? On the windows, right? So you get to look at the windows for that. Minus 2 tangent squared x minus 4 equals 0. All right, what do you think we're going to do now? Good, we're going to distribute. So 3 plus 3 tangent squared x minus 2 tangent squared x minus 4 equals 0. We're going to combine like terms. Excellent. So 3 tangent squared and negative 2 tangent squared is what? 1 tangent squared, right? And then the 3 minus 4 is going to be what? Negative 1. How do I move this to the other side? Add it. So tangent squared x equals 1. Okay, how do I undo the squared? Square root, and technically it's a plus minus square root. So really what I have is the tangent of x equaling 1 and the tangent of x equaling negative 1, and I need to find all of those answers. Okay, so we're looking at the sine divided by the cosine for tangent. What coordinate is the one that's the same? It's the radical, it's this, right? So we're looking at the radical 2's over radical 2, so we're really looking for all of these situations. So where are they both positive? So at pi over 4. The other one would make it, that would make it still positive, would be if they were both negative. So where's that? 5 pi over 4. Then I go to 1 positive and 1 negative. So there's 2 of those situations. So what are my other over 4s? 3 pi over 4 and 7 pi over 4. Good job. All right. The next one's different. Completely. Okay, there is no good way to turn one into the other at this point. But what I could do in order to get it into either sines or cosines is I could try squaring both sides. But watch how this happens. I got to put parentheses around that and square the whole thing. And then square this whole thing. What is sine squared allowed to turn into? 1 minus cosine squared. Thank you. All right. This thing here means let's FOIL it. Okay? So we've got cosine squared x plus 1 times cosine... I'm sorry, not cosine squared. Cosine x plus 1 times cosine x plus 1. I'm just putting that over there so we can see it. I need to FOIL it. That's what squared means. So what's cosine times cosine?
Cosine squared.
Cosine squared x. What's cosine times 1?
Cosine.
Cosine, and how many of those do I have? 2 cosine x. And then 1 times 1 is 1. All right, let's combine like terms. So I'm going to move these things to the other side. So when I move the 1 over, what do I do? Subtract. So the 1's going to go away, isn't it? When I move the cosine squared over, what am I going to do? So cosine squared plus cosine squared is 2 cosine squared x plus 2 cosine x, because we said the 1's are going to go away, equals 0. All right. What do I do now? What do you think?
Take out the 2.
Okay, I could take out a 2. Is there anything else I can take out?
Cosine.
I could also take out a cosine. What's left behind in the first term?
Cosine.
A cosine. Excellent. All right, what's left behind in the second term? All right, what property? Zero product property. I'm just waiting for everybody to catch up. I don't want to go too fast. All right, I divide by 2. I still get cosine x is equal to 0, so I need to know where the x value is equal to 0. So what radian measures does that happen at? Good. I need to move the 1 over. How do I move the 1 over? Subtract it. Okay, and so that means I need to know where the x values are -1. So where does that happen at? Pi. Oh, we still got lots. Okay. Let's look at 20. 20 is almost identical to this one. Okay. So, what do we need? How did we start it? What do we have to do to both sides? Square it. Okay. From there, I want you to see how far you can get with it. Okay. So take a minute or two. It's just like the last one, except that what? We have, I switched where the sine and the cosine were, right? Take a minute. Everybody try to get through it. All right, check mine. Did we get the same answer? Anybody who didn't get that answer needs me to explain. Speak up, because this is your chance. If there's something you don't understand, we need to take care of it. Okay, what's wrong? Where'd you get lost?
I don't understand how you change cosine to sine.
You don't understand this piece here?
Yeah.
Okay, so look, I want you to look up at the window up there. Okay, I want you to look at the middle window, and I want you to look at the first row, and I want you to look where it says cosine squared equals 1 minus sine squared. So I took this cosine squared, and I subbed in the 1 minus sine squared for it. Because they're equivalent values.
Okay.
Okay? From there, are you okay? All right, after that line, that was the trig line, right? The rest of it's algebra, right? It was the algebra, it's factoring. All right, are there any other questions on that one? That was a really good one. If you're not entertaining something, you got to get it down before the test. Today's the last day of new stuff, right? Tomorrow's study guide, test is Tuesday. Okay? I know. We're just going to squeeze one more in here before the triad. All right. We're going to use our calculator for these. You could use Desmos as well, okay, if you're doing this at home and you don't have a calculator. But let's practice. I want you to make sure you can do this in the graphing calculator because this is a skill we need for AP Calc. Okay, so use this in the calculator. So what we're going to do is put this in, okay, and I'm going to show you how to calculate. I think we've probably done this before. You can hit Doc B, okay. So we've got 2 secant squared. That's going to be fun. We got to figure out how to put the squared in there. Secant square or secant x. Okay, we got to be careful. I think we got to put in, I'm going to do this again. I'm going to go parentheses because it's weird with the trig. Secant x, and then outside the second set of parentheses, that's where you square it. If not, you're telling the calculator to square the x, not the secant. Okay? And then plus tangent squared. So plus, and I'm going to use parentheses again. When I want to square a trig, I start with the parentheses. And then the trig forces a parentheses. And then outside the second parentheses, that's where I square it. And then minus 3. And go ahead and hit the graph. Oh, we got lots. All right, but it gave us a domain restriction, didn't it? It said 0 to 2 pi. So let's fix our window. So we're going to go to the menu button. You're going to go to Windows, Zoom. I'm not going to try to zoom. I'm just going to go right to Window Settings. All I really care about changing is the x values. So I'm going to go from 0 to 2 pi. And I can type that 2 pi in, 2 and the pi. I'm going to click OK once I've got that done. So that, again, was under Menu, Window, Settings. Now it looks more reasonable, right? All right, so all you're going to do now is we're going to calculate the zeros. Do you remember how to do that? What menu? Where am I going to go from there? Analyze graph. Awesome. And then what? 0. So get your 4 zeros calculated. I'm going to go to Menu, Analyze Graph, 0. Menu, Analyze Graph, 0. And Menu, Analyze Graph, 0. Okay, write those 4 down. How many decimal points does Mrs. Ballard usually tell you? 3. I'm going to cheat a little bit. Yeah, I love copy and paste. As long as I'm copying and pasting my own original work, right? Oh, 22 is different. Okay, let's look at 22. What's different about it? It's not equal to 0, right? So I could make it equal to 0 and calculate zeros, but I can also calculate based on what's there. Okay, so I'm going to show you a second way to do this. Okay, so, and this is another good thing that we need to make sure we can do for AP. All right, so we're going to go for, I'm going to hit a doc B and get rid of all my hard work. Okay, and then we're going to type in 4 sine x, which that one's just the way it looks. Type in 4 sine x. All right. And then the other one was cosine x minus 2. You need to be careful. So it's cosine x outside of the parentheses is the minus 2. Let's make sure you type it in correctly. And then adjust your window again from 0 to 2 pi. So I'm going to go back to do my menu or my window adjustment. Menu, window zoom, window settings, 0 to 2 pi. So what I'm going to calculate this time is the points of intersection, which is still under the same place the 0 was. And it looks like I've got 2 answers, right? So I'm going to go to Menu, Analyze Graph. Where do you think I go this time?
Intersection.
Where it says intersection. And then it's the same thing. You go to the left of it, you go to the right of it. And all we're going to write down is the x values, not the y values. Okay, Menu, Analyze Graph, Intersection. Ooh, that wasn't it. All right, Menu, Analyze Graph. I went down too far. Left of it, right of it, done. Oh, maybe. Not letting me click. There we go. So there's my 2 points of intersection. I'm going to write down my x values as my solutions. Oh, I don't think I copied. Alright, so just grab those x values. We still got lots of time. Alright, we're going to try to do 3 more, okay? The last 3. So we're going to do 23, 24, 25. If we do those, you should be fine on the homework, okay? And these ones are pretty short. You still need your unit circles. Okay, we're going to solve it just like we've been solving. The big difference is, see how there's a number next to the variable inside here? So that's going to act just, we're going to tweak it just a little bit. Okay, so what do I do to move this 1? Add it. So cosine 3t equals 1. And then what am I going to do to move the 2? Divide. So cosine 3t equals 1/2. At this point, I still need to know, where does the x value equal 1/2? So what radian measures does that happen at? I like that. Where else? Okay. Remember how last time I would say x equals, or whatever that was inside there equals those 2 things? Well, instead of an x, it's a 3t. So I'm going to say 3t equals that, and 3t equals this. I still need to solve for t. How am I going to get that 3 to the other side? Divide by 3 or multiply by 1/3. It's one additional step to what we were doing before. Okay? So t equals pi over what? 9, and t equals 5 pi over 9. You see the essential question? Solve quadratic equations in trig equations in quadratic form. We did that a lot today, but this is the containing more than one angle part. Okay, that's a multiple angle in there when we have something times the variable in the center. Okay. All right, let's try it again. I have to move everything first, right? So how do I move the 3? Good. So we move everything off the trig first. So subtract the 3. What else do I have to move? Yeah, we got to divide that other 3. So when I divide by 3, what do we end up with? -1. So I need to know where the tangent is equal to -1. All right, so that happens when I've got the square root of 2 stuff going on, right? But I don't really know where that negative is, right? So I really need to look for the coordinate negative square root of 2 over 2, and that, and then positive square root of 2 and negative square root of 2. So what 2 radian measures does that happen at? 3 pi over 4 and 7 pi over 4. And then these are, we take whatever's in there with the trig and we set those equal to those radian measures. This time, how do I move the 2 to the other side? Multiply it. So let's see, 2 goes into 4 2 times on both of those, right? So our x value is 3 pi over 2 or 7 pi over 2. All right, I don't know why I saved the easiest one for last, but apparently we did. All right, so I need to know, I can't find secant on my unit circle, but what can I find on my unit circle? Cosine. So really I'm going to do the cosine of 4x equals what? 1/2, right? I got to flip the reciprocal. All right, so I need to know where the x value is equal to 1/2. So what radian measures does that happen at? Pi over 3, where else? Good. How do I move the force? Divide or multiply by 1/4. We've got x equals pi over 12 and x equals 5 pi over 12. Yeah, and then it's the same, kind of the same thing on 26, so I'm not going to mess with that one. Okay? All right. Let me really quickly put your assignment up into haiku. I think I've got it somewhere here. Let me find it. Make sure I've got it up there in the right spot. I think I built it. Oh, no, I think it's already there. Let me look. Is it already there?
Yeah.
Yeah, it is. Okay. So notice, I made it today's assignment and tomorrow's assignment. Okay? But I'm going to take questions on it tomorrow because we've got